3.4 function notation, I think is what it's called. Something of that, something with dealing with functions. This is one of my faves. Love it. Evaluate the function when x equals -4, 0, and 2. So these are our inputs. We're going to input each of these x values individually, separately, and we're going to plug it into this function. And when it says g of x, when x is -4, we're going to say g of -4. So where we see x, we're going to plug in -4. So 5 times -4. So it's important that we saw that that -4 is the value we're plugging in. So where we see x, because that's my x, I'm going to plug it in wherever there's an x in the formula. So g of -4 equals 5 times -4. So g of -4 equals -20. And then if we write g of x equals 5x, and this time we're going to plug in 0. 0 for my x value. So wherever we see x, we're going to plug in 0. So g of 0 equals 5 times 0. Notice all the places we had an x, we inserted a 0 for that value. And then we'll simplify. G of 0 equals 0. And then we do that for the last input, which is g of 2, I think it was. G of 2 equals 5 times 2. So g of 2 equals 10. Good? All right. That should be pretty simple. So s of -4 equals 12 minus 0.25 times -4. S of -4 equals 12 plus 1. And s of -4 equals 13. We're going to plug in 0 for our next function. S of 0 equals 12 minus 0.25 times 0. S of 0 equals 12 minus 0. S of 0 equals 12. And the last value again is 2. So we plug in 2 for x. 12 minus 0.25 times 2. S of 2 equals 12 minus 0.5. S of 2 equals 11.5. And those are the three solutions for that. Third one, t of -4 equals 6 plus 3 times -4 minus 2. Now, hey, here's something that not a lot of students know. You can simplify this prior to substituting it. We can simplify functions, and we could write that because those are equivalent. So if you want to do that in order to sort of make it a little bit more efficient, 6 minus 12 minus 2, -6 minus 2 is -8. And let's check and see. If we plug in -4, we still get that. -12 plus 4 is still -8. So I'm going to use that simplified function. And we're going to use it for 0 equals 3 times 0 plus 4. So t of 0 equals 0 plus 4. T of 0 equals 4. And then we'll do it for 2. Equals 3 times 2 plus 4. All right, I think I'm doing it correctly. Yeah. Oh, yeah, sorry. Yeah, we're good. T of 0 equals 6 plus 4. And t of 2 equals 10. All right. Let n of T be the number of video games you have in your collection after T trips to the game store? Explain the meaning of each statement. So N of T you have in your collection after T trips to the game store. Okay, so, yeah, we won't, that's not true. That is not the equation. So remember, this and this are the same, because this is an output, and that output equals 8. And then this value, the inside value, 0, represents T. So we have N of T is 8. Well, N of T equals, yeah, so this is a simplified version. So after 0 trips, you have 8 video games. So what do we know about how many video games we start with? So we have 8 video games before we even go on a trip. So my initial number of video games is going to be 8, because if I haven't taken a trip to buy any, that's how many video games I have. N of 3 of 14 is after 3 trips, I have 14 games. You see that? And after 5 trips, I will have more games than when I made 3 trips. So these are the number of games. This is the number of games I have after 5 trips. This is the number of games I have after 3 trips. And so the games here are going to be games here. G sub 5 is going to be bigger than G sub 3, the games, right? I know there's no variable G, but after 5 trips, I'm going to have more games than after 3 trips. So this is the number of games after 7 trips minus the number of games after 2 trips. If I subtract those, I'm going to get 10. So I have 10 more games. I have 10 more games between these 2 trips. I have 10 more after 5 trips. Sorry, 5 trips equals 10 more games. So I've acquired 10 more games in those 5 trips. Yes, that's a good one. I don't know if people knew that. Not very many people are going to say that. They're just going to say after 7 trips to the game store, I have 10 more video games than I had after 2 trips. But this is really how we can derive it. That's pretty good. In exercise 5 and 6, find the value of x so that the function has the given value. This is great. So we know this is my output, and my output equals -20. So when I see this equation, b of x equals -3x plus 1, I can substitute these. I can substitute this value in for this. So when I see this, I can plug in -20, because those are the same. So I could write this statement, -20 equals 3x plus 1. And what do we love about this is we're left with one variable. So -21 equals -3x divided by -3 divided by -3. So I'm able to find my input. So I could make the comment now that b of 7 equals negative 20. And if I plug in, that's negative 21 plus 1 is negative 20. Yeah. So I can write that. That's not what they're asking. Just understand. This is an understand. This is the answer. So they want to know what x says, find the value of x. That's here, but understand that that also is true. That's a statement that we can derive. So same thing, we're going to take this value and plug it in, or exchange it, substitute it for that value. So instead of writing m of x equals negative 3/5 x, we're going to substitute 2 in for m of x. Then we're going to multiply by the reciprocal, which is negative 5/3. Negative 5/3. We cannot cross cancel here. So we have negative 10/3 equals x. And that's our answer. Also understand that m of negative 10/3 is going to equal 2. Because when we plug in negative 10/3 into our x, we get 2. In exercise 7 and 10, graph the linear function. Oh, I should have put a graph in these. Sorry about that. Graph the function. So there's a couple ways we can do this. We can find 3 points. We can make a chart. And we can do input, output, input, output. Notice I didn't write y. And this is going to be x. This is going to be k of x, axis. So I can plug in 0. And I would get 0. Let's do this. Well, yeah, we can write that. K of x equals negative 3x. If we're going to make a real. So k of x equals negative 3 times 0, which equals 0. We can plug in 1. Oh, I could go like that. Sorry, I should be writing, notating it that. Negative 3 times 1 equals negative 3. And we can plug in negative 1. K of negative 1 equals negative 3 times negative 1, which gives us 3. And we have 3 points. We have 0, 0. We have 1, negative 3. And then we have negative 1, positive 3. So my graph looks like that. Well, let's do this because we're good. Oh, landed it. I think they say stuck the landing. So that would be graphing the linear function. The other way we can do this, which I hope some of you, I didn't mean to do that. No, Mr. Mac, delete. The other way we could do this is let's clone the page. Let's erase those points. Let's erase this. Let's erase this. Delete. The other way is we know that this is a linear equation because it's written in the form of y equals mx plus b, or k of x equals mx plus b, where m is the slope and b is the constant. The m in this equation is going to be the coefficient of x, and that would be the slope, and the y-intercept is going to be whatever is being added and subtracted. So my slope equals negative 3, which is negative 3 over 1, which means down 3, right 1, down because it's negative 3, right because it's positive 1. And then my y-intercept is going to be 0 because there is no number being added and subtracted. We always plot the y-intercept first at 0. Then we're going to go down 3, right 1, down 1, 2, 3, right 1. And we again have that same line. Oh, wow, I'm getting pretty good at drawing those, getting those lines on the first shot. And so that's the other way we could do number 7. So keep in mind, yeah, we kind of haven't learned this plotting. That's going to be, I think, in 3.5 or 3.6. So either way, though, this was taught in 7th grade. Let's do this one. I'm going to use slope-intercept form. The thing about this is that's not in slope-intercept form. It should be t of x equals negative 2x plus 1. We always want the variable x first and the constant last. So my slope is negative 2. My y-intercept is 1. So I'm going to go at 1 on the y-intercept, and my slope is negative 2, which is up 2, right, down 2, right 1. See, I should have written it. Negative 2 over 1, which means down 2, right 1. Down 2, right 1, down 2, right 1. A little bit off on that one. Did not stick the landing on that. There you go, though. Good. That's that. Let's put arrows. Always have to put arrows. And those are my points for that linear function. And we always want 3 points. You should always graph 3 points. This one is in slope-intercept form, so I don't have to rewrite it. I do have to pull a graph out. And my slope is going to equal 1/2, which means up 1, right 2. My y-intercept is negative 2. We always start at the y-intercept, and we use our slope. Up 1, right 2. Up 1, right 2. Connect those lines. Again, kind of good, but not perfect. That looks a whole lot better. Arrows and plotting 3 points. In the book, it looks different. Why does it look different for 9? That answer, S of x, that should be plug in 0. Plug in 0, you're going to get negative 2. They made a mistake in their answer key. Shocker. No shocker. It does have proper slope, but the y-intercept is wrong on their answer key. All right, let's do number 10. We have a slope. Ooh, I like this. Slope of 0.4. Now, we could make that a fraction, 0.4 over 1, but who wants to go up 0.4 and then write 1? Yuck. Excuse me. Instead, I'd rather write that as 4/10 or 2/5, which is up to right 5. To me, that's much better. My y-intercept is going to be negative 3. So decimals I'm going to convert, unless it's a repeating decimal, which I don't know. Yeah. So let's plot the y-intercept first. And then we're going to go up 2, 1, 2, right 1, 2, 3, 4, 5. Up 2, 1, 2, 3, 4, 5 takes us there. 2, 4, that's 5, good. And that's 1, 2, 3, good, yeah. So their answer key is correct on that one. That's good. Let's just raise this just a tad, lower that tad, and we get those points. Good. That's how I would be graphing these functions. I would not be plugging in points. That's just too time consuming. Labor intensive, as they say. The function b of m equals 50m plus 150 represents the balance in dollars in your savings account after m months. Okay, so b of m equals the balance, and m equals the number of months. I like that just knowing. The table shows the balance in your friend's savings account. Who has the better savings plan? So we don't have any data points for our situation. This is my friends over on the right here. So I have to find some data points. So we're going to input m. We're going to use this function. And we're going to produce the balance, b of m. So if we plug in 0, we get 150. Do I need to do that? Hopefully I don't have to show you why that would be the case. After 1 month, we would get 50 times 1 plus 150, which is 200. 2 months. Notice I didn't go negative. Why didn't I go negative? Because you can't have negative months. 50 times 2 plus 150, which is 100, 250. Okay, so I can take that, and after 2 months, so we're going to see the table shows who has the better savings plan. Okay, so there's a couple things we can do. We can make a graph, and we can chart it, and we can look at my data plan or my savings plan, which looks like this. What are my increments going to be? My increments on my m, so this is m, and this is b of m, which is my balance. So my balance, I'm going to go, am I going to go by, we're getting up to 490, so that's pretty big. So 50s? Let's go by 50s. So 0, 0, or 0, 150. So 0 in green is 50, 100, 150. And then 1 is 200. And 2 is 250. Because it's 50, 100, 150, 200, 250. So that's good. And we can draw, let's do it in green. That's my green. So we're going to get that, and it's going to have a slope of 50. It's a constant rate of change. Now let's look at this balance. Let's pick colors. Let's do blue, 2, 330. So at 2, he was at 330. So 51, 2, 330. So something like that. 2, 330. 4, 110. So 4, that's 2, 4, 1, 2, 3, 4, 10. And at 6, he's at 490. So 6, so 490, 1, 2, 3, 4, 5. Well, that looks like it's moving in a direction that is going to change over. If we stretch this out, and what we can do is see, do I overtake him at some point? And that needs to be moved just a tad, like that. And if we stretch this out, I'm assuming, right, that's going to cross over somewhere. So we can stretch that out to show the change over. So let's test something out here in the months. So let's just, we know that in the beginning, after 2 months, he has a better plan. After 4 months, he still has a better plan. But I'm assuming, let's try like 9 months and 10 months. So, do you know what 9 is going to be? So let's find out what that slope is. Can we calculate it? So that is going to be plus 2. This is going to be plus 2. This is going to be plus, that's 780 plus 80. And that's going to be plus 80. And so we can keep going if we wanted. 8, and that's going to be 570. 10, and that's going to be 660. No, 650. All right, yeah, 650. So let's go and do this one. Let's go and plug in for our balances. Let's do 8 and 10. So in black, if we do 8 months, what do we get? 8 times 50 is 400, so that's 550. So we're close. He's still better after 8 months. 10 months is going to be, so are we tied at 10 months? Yes, we are, 650. So after 10 months, we have the same, and then I'm going to pass them after 10 months. So after 10 months, I'm going to have the better. Okay? Does that make sense? So the table shows who has the better savings plan. He has the better savings plan initially. At 10 months, we have identical savings. But after 10 months, I have the better savings plan. Cool? That was good. I like that question. A lot of comprehension there. Let f be a function. Use each statement to find a point on the graph f. F of 1/2 is equal to 6. So we know the point is 1/2 6. Oh, there you go. Yeah, because our coordinates going to be x comma f of x. So this says f of x equals 6. So yeah, that's our point. What's a solution of the equation f of x equal of the solution of f of x equals 7.2 is 9. That's an interesting, so I'm assuming, so, well, we know these are the same, so I know that's my y value, and this is my input, I mean, that's my, so I'm going to say that the point is 9 is my input, and I get 7.2 as my output. That's not very well written. Number 13, last one. Let g of x equal 16 minus 8x and h of x equal 1/4 x minus 6. Yes, here it is. Find g of h of x. So what am this? Here's the fun part. So x is the input of the function h. And then h of x is going to be the input for my g, will be my x. So I'm going to insert, that's my x value. So h of x is equal to this. So I'm going to enter that into that equation. That is a really good big brain one. So we'd say g of h of x equals 16 minus 8 times the quantity 1/4 x minus 6, because we are substituting that in for my x, yes. So g of h of x is equal to 16. We're going to distribute to both of the terms. -8 times 1/4 x is -2x. -8 times -16 is positive 48. We're going to combine like terms. So g of h of x equals -2x plus 64. Good. That's it. That's the answer. We can't simplify any further. Yeah. Love 3.